Hello, good morning to everybody. Students, the continuation of power load estimation for diploma, electrical estimation and installation subject EEE 505. We are going to continuing study of different application of power loads. So this today we are going to very interesting and easy method of power calculations in agriculture field. You can see for farmer he is going to use different 3-phase squirrel cage induction motors at his fields away from its home. So what are the different protective devices to run the motor without any overload and short circuit or burnout? Today, what are the different type of the devices required for ideal condition of induction motor, and if the problems occurred, what are the different devices to protect the motor from overloads as well as the fire accidents. Students, so let us see. Before that one, so once again my introduction. I am C.H. Yadaya, Senior Lecturer in Electrical Engineering, Government Polytechnic, Usnabad. Today topic is regarding to electrical estimation and utilization of 5th semester electrical diploma students. In second chapter, the subtopic is wiring layouts of estimation for agriculture pump sets. Let us see what are the today objects. On completion of this period, we would be able to know about types of wiring and service mains used for irrigation pump set, various materials required for irrigation pump set installation, calculation of materials required and estimating their approximate cost, and finally the preparing the estimate for electrifying an irrigation pump set, that is a schedule. These are the steps involved to know basic idea of irrigation pump sets. As you know, you can observe here, in the olden days they are using the nearby wells, open wells for domestic purposes as well as agriculture purposes by using small devices, where at that condition the water level on the earth is nearby nearly some feet, 10 or 15 or 20 feet only. At that condition they are using as a different type of the buckets to take the water from the well. At the same time, for agriculture purpose, generally the people used a runoff river during the rainy season. This water is used for agriculture purposes. But what is happening nowadays? The population increasing enormously. The food manufactured by the different farmers and industries day by day has to increase to cope up the low demand of the consumers. We have to generate a large amount of the food products, hence we require the different type of the devices to cope up the need of consumers. At the same time, by using natural resources day by day in very high level, so the water level depletion takes place and carbonization as well as what do you call it, this is the greenhouse effect and pollution of air pollution, ground pollution, water pollution, the water depth of the water is going on decreasing day by day. Now, if you are observing some cities, for example, in case of Hyderabad, the water bore itself they are taking the nearly above 600 meters, 600 feet or 1000 feet or 1500 feet to take the water from the ground level. Hence, at that condition, that much of the depth water has to drive outside, we require the strong devices. Those devices are known as the pump sets. To run the pump sets, we require some other devices. Those devices are our electrical devices. Let us see what are the devices. If you are observing here, this is a one open well. Previous days they are using this water level is very nearby this one ground, and nearby a pump shed. From this pump shed they are using for agriculture fields. Nowadays they are using the very high capacity different types of the motors, pump sets to drive the water from very depth of the earth. So these are the latest development from normal domestic where they are using some small items to take the water from the open well. Nowadays we are using nowadays if you are observing, open wells are very rare and only submersible pumps are go on increasing to take the water from the very low, very high depth, nearly above 600 meters, 600 feet, 300 feet nearby, that is the lakes or rivers. Let us learn what are our electrical devices to help the farmer to do the agriculture fields. So let us see. Now, as we know that these electrical motors may be two types. One motor you can see here, the first figure, where it will take the motor will placed outside of the water and it will create the suction inside and it will take the water and pushes the water towards higher side. This is the open well motor. Whereas sometimes we can use the submersible motor where motor itself placed in a water. That means, so here development of the motor, as we know that our electrical motor is a very dangerous while you are using the water. But what will happen? So latest technology, latest insulation materials, so we can use our motor in immersed water, submersible water. You can see the latest technology. Now sometimes we can use this type of the motors also, how the installations were taking place. Here is one motor placed inside the water tank or a well where the non-return valve is provided to avoid the water to return, and water is placed and supply the cable is a waterproof cable is given to this one. Motor also yoke and everything is sealed with a perfect insulation, and this is known as a submersible pump set. So for the low level open wells, sometimes we can use a high depth level where more than 100 feet, 200 feet, 500 feet, 1000 feet, then we can use the one small size of instead of this shape, different shape of the motors also used for this one. We can learn tomorrow that type next day. Now let us see the open well, this one. This is a submersible, now open well. So our motor is placed out of the water level. So you can see here. So here you can observe this is a open well, the near to agricultural fields and near to small village or hamlets, where the water is utilized for the agriculture as well as the home domestic purposes. Now we have to drive the water from the well to outside. So that purpose we require the pumps. The pump has to driven by our electrical motor. So similarly, whether single phase motor or three phase motors generally used. Most of the the agriculture fields are worked on 3-phase induction motor only, whether it's a 5 HP motor, 7.5 HP motor, 10 HP motor. Sometimes they can use a 15 HP motor also used for based on their requirement. Now you can see by using our electrical motor how they are enjoying this one water. So this water taken from the nearby well for the agriculture fields. The open well motor near to agriculture fields, the farmer is enjoying the water by using our electrical motor. Now let us say, so our electrical, regarding to our electrical system. So type of wiring and service main used in for agriculture pump sets. So that means here types of wiring and service mains used for irrigation pump sets. That means here, so we are taking the supply nearby pole to our pump shed by using the two methods. One is a overhead line or underground cable line. So most of the farmers are preferred for overhead lines only. That is a service mains. The surface metal conduit wiring and ICTP, iron clay triple pole switch mains are used for installation of irrigation pump sets. Now what is the next thing? Now here is the current rating of iron clay triple pole switch depends upon full load current of motor, whether it's a motor is a 5 HP motor, 7.5 HP induction motor or 10 HP induction motor. Based on this one, it will decide the ICTP rating. Now next factor is the size of conduit depends on the size of cable and number of wires run through it, whether the cable is 24.5 mm cable or large. That's based on the number of wires we require to drawn through this one. So here we are using the metal conduit only. The size of the conduit, that's the metal conduit. Is the power load always use the metal rigid conduit or flexible conduit for this agriculture purpose also. At the same time, whenever used this metal conduit, that should be earthed, that should be remembered. And next, what are the factors? You can see here. So the basic idea of this agriculture total field. Now you may given the nearby pole or shed. It is assumed the 15 meters from pole to our shed switchboard, you can say. So from this one, it is the 3-phase supply is available RYB neutral. So by using the 6 square mm, the aluminum wire generally we taken as a service wire, twin core. So we can use R phase, Y phase, B phase, and neutral we taken the double wire. So 2 core service wire taken from pole to nearby our pump shed is a 15 meters. So plus or minus 1 meter, that is nearly we will take the 17 meters into 2 times. So 34 meters of a service wire is required to take the supply from the pole to our shed. So here our roof of the shed we are going to place one stay wire to pull the by using the GI wire in a to avoid the very loose sack. Now from that one, so we taken inside through the PVC metal conduit, sorry, is a metal conduit through the metal conduit. And so you can see here the SB, this is a switchboard or meter board or distribution board. From this one we are going to connect the motor pump set. So through the metal conduit, sometimes where the length is very less than the 30 centimeters, then we can use the flexible metal conduit. You can see here. So these are some basic idea. Now this is a service wire, you can see it, and this is a service wire. Next here is a service cable and motor shed and switchboard and conduit, and this is the motor, and this is the valve. So these are the basic idea about the what is our power shed, that is the motor shed, and PSCC pole nearby, and how much distance from pole to how we are going to take the supply from by using the overhead service wire or by using the underground cable to nearby our switchboard. From switchboard to motor pump set, how we are going to connect. So what are the different protective devices required? Let us see. These are the basic idea. So for example, here is a one room is given where the room size, the motor shed room size is given, is a nearly is a 5 meters is the length, and the width is a 3 meters. Height is maybe obviously 3.5 meters height of the this room. Now, so we taken the supply to the switchboard nearby that place, and from switchboard to the 5 kilowatts pump is I want to install nearby this corner where it is near to the our open well. So here our motor has to be installed. So away from the this wall 1 meters and away from the 1 meter this side. So we have to keep the some distance for the good ventilation. So we have to place this 5 kilowatt pump so away from the 1 meters from the width and length. Let us assume we are going to place one plinth where we are going to install our 5 kilowatts 3-phase squirrel cage induction motor. So this is the idea. This is the room size. So based on the room size, we are going to estimate what are the different type of devices required, what are its ratings, and how many the devices is required. So we are going to prepare the one schedule, approximate cost, how much cost is going to we are going to estimate these materials. Let us see. Now here is the so same thing, switchboard and motor terminals. Now we know that as per the IE rules, so we have the some basic IE rules. What are the rules? Here we are going to provide the ICTPN, iron clay triple pole and neutral link. So with the pilot lamps and as well as single phase preventer and starter. These are the protective devices for our motor. And these are the placed one common board nearby the meter board. As you know that in some other states, even agriculture farmer also has to pay the some amount of the tariff for month bill, electricity bill. So that purpose, how much energy is taken is measured by the 3-phase energy meter. Here we are as in our Telangana, I think the most of the agriculture fields, they are not using the 3-phase energy meters. If standard point of view, so we have to place one energy meter before ICTPN switch, where it is the input value measures. So from the pole to energy meter, from energy meter to ICTPN, from ICTPN to the protective devices, that is a single phase preventer and a starter. From the starter to the motor is another connection. Now, so here, so energy meter, ICTPN switches and single phase preventer and starter, whether it's a dual starter or starter starter, has to be placed in a one nearby distribution board where it has to place nearly 1.5 meters from ground floor. At the same time, that may be horizontal run has to run so below the 0.5 meters from the roof. Let us assume this height of the room is 3.5 meters. That means the horizontal run the nearly 3 meters. So next it has to place the total length of the room is 3.5 meters height of the meter. So these are the as per IE rules we have to follow. So what is the where we are going to draw the horizontal run and vertical up and vertical down based on the previous assumptions. Now based on the room, now it is the room size is the already we know that is nearly 5 meters and 3 meters. So based on this given size, we are going to calculate the length of the conduit, the metal conduit, flexible conduit, length of the cable, and number of devices. This is the number of elbows, number of junction boxes, and saddles, and some accessories. What are the accessories? We are going to estimate. We are going to mention in a table, that is on the schedule. That is our aim. Now let us see. So what are the device physical? This is a theoretical parts. If you are observing in a agriculture field, if you are visited any pump shed nearby a farmer, so you are going to observe same ICTPN, single phase preventer, and starter and meter. So what do you mean with the single phase preventer? Let us explain later. Now before that one, ICTPN already you have seen, iron clay triple pole switch. So what is it contains? So before this one you can see the figure, real figures. Now so electrical devices for pump shed. Now here what will happen? This is a ICTPN switch, the iron clay triple pole switch. This it has a porcelain KitKat fuses inside, and neutral link is inside, and this can be operated 3 phases at a time on a purpose. So it is inside the fuse. The fuse wire is based on the motor rating. Now another device is a single phase preventer. So this single phase preventer, what is the purpose of single phase preventer? So because what is happening? So the farmer, so nowadays what will happen? The power may not be meet the load demand. The generation of our electrical power may not be sufficient to feed 24 hours to the load demand. That means here the load demand is more in our country and generation is less. So that purpose what will happen? The NPDCL people, or this is DISCOM people or TRANSCO people, they are going to manage the power. That means so total generated source of energy is supplied to the different load consumers based on their by load shedding. Load shedding means so 2 hours power cut to this area fields for today, and same 2 hours for the other fields for the next 2 hours. Such a way that they are going to scheduling the power distribution. So what will happen? Once the farmer switched on the supply, then if he comes to the village for their any purpose, so the supply will gone for the just 1 or 2 minutes, then will comes once again. What will happen? The motor has to start manually once again, or sometimes the NPDCL, the TRANSCO people or DISCOM people, they are what they are doing to meet the load demand. Some from morning to evening they will give the 3-phase supply to the agriculture or industries and domestic. After some period, for example after 8 o'clock in evening, they are going to give the only single phase supply. That means so instead of RYB, they will give from the substation itself, they are giving the instead of RYB in 3 lines is going to the only R phase lines. That means Y and B 2 lines are open by using the isolators. That means so what happened? So 3-phase motor which is connected to the previously to these lines is try to run, but what will happen? It is only single phase. That is we know that as an electrical student, each phase has the line to line voltage of 440 at an angle of 120 degrees apart. So instead of R phase, so 3 lines are going to only R phase. There is no phase. So 440 volts is the magnitude, but displacement is the 0 degrees only. So not 0 degrees or 120 degrees and 240 degrees is required. But what will happen? 3 magnitudes are 440, or we can a single phase, so the 230 volts, and angle is 0 degrees. So what will happen? Motor will not run. So if the single phase is given, it will try to draw the more current to run the motor. So at that condition, so due to the low voltage, the motor will burn out. That means so whenever sometimes they will give the instead of single phase, they will give the only 2 phase. So one phase is open. So, these two phases will take the motor, try to run the motor due to the from less amount of efficiency, the motor will try to draw more current. Due to this heavy current, large current, the motor will be heated up and burn. To avoid this one, so the motor is designed to run whenever the three-phase supply is available in the line only itself. If any two phases, one single phase comes, the motor does not run. So, they will use this single phase preventer. That single phase preventer means the motor, the pump set will start whenever the three-phase supply is available in the line. That means R phase is a 440 at 120 0 degrees, and Y phase the 440 volts at 120 degrees, and B phase 440 at angle of 240 degrees. That is RYB displaced with the phase angle of 120 degrees should be there. At that condition, motor has to run. Under normal condition, it work without any harm. So, at that condition, so if due to any technical problem, due to the wantedly problem, so if the lines, the current will come only two phases or single phases, then the motor does not work by using this single phase preventer. If single phase presents, automatically switch off our motor to avoid burning. Now, what is another? So, D-valve starter already you know. So, D-valve starter, direct online starter, the protective purpose we are using the motor. Now, so these are the basic address ICTPN switches or three-phase energy meter and single phase preventer and D-valve starter. These are the things we are going to. And what are the main things? These devices are used to run the different of the motors. What are the motors? You can see, observe here. So, these are the different type of the motors from the different companies, different shapes, and used to in agriculture. Now, this the devices generally present in electrical locus shed nearby farmer. Now, you can see that. So, what are the some assumptions? Now, let us see the our problem. So, we are going to make the one schedule. That purpose, before we are going to making the schedule, we are going to assume some values. So, what is this is a motor, this motor efficiency. So, these are different motors having the different sizes. What is the efficiency and what is the power factor operating conditions? So, what is the voltage? We are going to assume this thing. First of all, let us assume now the following assumptions are made for estimation. What are the estimation? So, motor efficiency is 85%. This can be used at while calculation of input current. At the same time, it is going to assume is operating at 0.85 lagging. Now, so distance from LT pole nearby PCC pole to our motor shed meter board or pump house nearly the 15 meters. Next, height of rope in the pump shed is 3.5 meters from the ground floor. We are already taken the dimension of the room. Now, height of panel board and switch board is 1.5 meters from ground. Next, the height of the horizontal run, so already we have assumed that is 3 meters from the ground floor or 0.5 meters from the rope. And next, cable. So, what is the cable size? The cable size depends on full load current of pump motor, the capacity of the motor, whether it is a 5 HP motors or 10 HP motors. Next, length of the cable and conduit, length of the conduit depends on the dimension of pump shed dimensions. Now, we are taking the is what we are taking the 5 meters into 3 meters. Sometimes the pump shed may be, the dimensions may be vary. Based on the dimensions, we are going to install the motors. Now, next, and 720 SWG, the aluminum weatherproof twin core cable, service cable, that may be service cable, is used for connection of supply from nearby pole to our pump motor energy meter. And last one, this is this service cable length depends on the distance from the pole to our shed. So here we assume the 15 meters. So these are the some things we are going to keep in our mind doing the preparation of schedule. Now what are the materials generally required for agriculture? Let us go at a glance. Similar to the previous case. What we have said, the power loads in a small industry and electrical lab and big industry and the milk dairy at different places. So how we are going to prepare the schedule? Similarly, we are going to prepare here also schedules. So now let us see the what are the materials, general materials required. Now here 32 amperes 500 volts 3 phase ICTPN switch with fuse units is required 1, and starter also we required, whether the dual starter and the dual 3-pin starter is required 1, single phase preventer is required 1, and panel board, that is a 50 into 30 into 20 the centimeters size, this is the one, and 2.4 metal conduit of pump. So depend upon the location, the metal conduit, that is a we are going to lay here metal conduit. The size of the, we are going to find the length first of all. Next 2.5 flexible conduit also required, where the length is very less. So previous case where the rigid conduit and flexible conduit, this is a metal conduit that should be earthed. And another is the copper cable of pump, that is depend on the size of the motor. Next 1 square copper cable for indicator lamp, that is here we are going to place the 3 indicating lamps. That gives the idea to the farmer, so whether the 3-phase supply is available or single phase supply available, even providing the preventer. At the same time it will give the illumination to the shed also. So that is a 1 square that is a 118 copper wire is enough for connection of R phase, Y phase, 3-phase pilot lamps. Now next, so another is angle small frames, angle frame 15 to 30 centimeters angle frame to used for service wire, nearby this one. 8 SW earth wire, earth set is required, and 1 ammeter also required, 1 voltmeter also required to know the how much current is taking the motor and how much voltage is coming from the supply. We are going to measure by using this voltmeter and ammeter also placed on the panel board. And cement and dangerous flares, indicating lamps, 19 dia, GI earth sets. So these are the common materials generally used in any power system. Next, after these are the few basic materials, and to arrange these materials in a systematic order we require the labor cost. So labor cost depend on the electrician charge plus helper charges. 2 persons is required to install this total things. That's that into number of days, how many days it taken to complete this work. Here the lineman connections charges plus local electrician charges. So nowadays we are observing the lineman only will give the connection to the connection on the pole itself only. So remaining all things, service wire, clipping and installation of ICDP switch, energy meter and everything arrangements is going to do the local electrician only. So the lineman only is intended to give the electrical supply, authorized to give the electrical supply at the pole. So even then he is taking the some charges. So this lineman charges plus local electrician charges we are going to pay as a labor charges. These are the basic idea of theoretical idea of agriculture. Now based on this one, so we are going to do the one example how we are going to do this one. For example, so this is based on this basic ideas we are going to estimate installation of agriculture pump sets. Then so if it is successful we are going to get the water. Similarly the here you can observe here how the agriculture pump set is running by using our electrical supply. Let us do. So what are the next, we can take the one example. So example for agriculture pump loads, this is a method. So now we are going to do this one. How we are going to do? As an electrical student, first of all we have to keep in our mind so how the electrical wiring diagram from energy meter to pump set, that should be remembered first of all. So what are the connections, how we are going to give the connections for the from energy meter, ICTPN, single phase preventer, starter to starter or dual starter and motor connections. This is going to do by the wiring diagram. Let us do one example wiring diagram for a 5 kilowatts three phase squirrel cage induction motor from supply. Now you can see here, one is the black one is the energy meter, and next is the energy. From energy meter we will take the 4 wires as an input. You can see here three phase R by B, and N is a black one. It is going to the input is a 4 wires input and 4 wires the output. From energy meter output is given to the iron clay triple pole and a neutral switch, where it is a 3 phases consist, and from output we are going to given to the single phase preventer. In between we are going to connect the ammeter in series in one phase. Here we connected the R phase, and voltmeter we connected between the 2 phases R phase and Y phase, that is the line voltage. At the same time 3 lamps are connected in each phase. So R phase, Y phase, B phase, 3 lamps are indicating lamps. We can say pilot lamps is connected. A 15 watts lamps are provided to indicate whether the 3 phases supply is coming or not. Now next we are connected the, so you can see here this is the indicating lamps, indicating meters, that is the ammeter and voltmeter, and here is the pilot lamps. Now here is a pump shed. This is a wiring diagram you have to keep in your mind. So after knowing as an electrical student by drawing the wiring diagram, so we are going to how the pilot lamps, how the voltmeter, how the ammeter has to connect it, and so based on these things we are going to estimate the values. Now this is the wiring diagram. Realistically you can see here, so how the ICTPN switch 3 phase MCBs, and how the single phase preventer, dual starter, that is also you should know. Now you can see that at a glance here another example of wiring diagram of pump set. Here RYB neon, so 3 phase MCB is provided and is connected the another, you can see here this is the, here is the 3 phase supply MCB, and it is connected to the dual starter direct all-in starter setup. So red button and green button at the same time. So you are going to use it the run, stop and trip. So another productive release also provision is provided, and single phase preventer also provided by the another connection. So these are the things you to learn. Next, after this connection we are connected to the 3 phase motor here. So this is a practically, so how the MCB, how the single phase preventer and how the dual starter connections connected you can see at a glance. Now you can see the single phase preventer. What is the important of the single phase preventer? You can see the by seeing the figure here. Now you can see here clearly here the single phase preventer. So what is the purpose single phase preventer? Whenever 3 phase supply comes, then motor has to run. If any one phase fails, any 2 phase fails, then there is no supply to the single phase or 2 phases, then motor has to stop. That is the work is assigned to single phase preventer. Single phase preventer will work only whenever the 3 phase supply is comes, then it will run the motor, otherwise stop the motor. That is the, so thereby it is avoiding to burn out the motor or overriding the motor. So you can see here, so how it is connected here. Now it is the same thing similar to this one, and here is a 3 phase MCB, and next we are connecting the dual starter and overload relay that is provided, and this is a single phase preventer, and this is the 3 phase energy meter. So how the single phase preventer is connected you can see here. RYB neutral is connected to the same, coming to the before overload relay, before that one is given to the single phase preventer. At the same time it is connected to the normally on push button green color, the left side you can see here, and is the normally closed push button, and emergency button also provided in case if anything happen. So these are the some protective devices also provided in case of agriculture pump set arrangements. So this is a latest diagram you should know. Now coming to the after this one, let us assume so our diagram. So here similar to this one our diagram, wiring diagram. Now what is happening here? Now how this is works? So as a student, how the supply will go from input to the motor. What are the process? How many stages we are going to control the electrical supply? Now the input is coming from the RYB neutral and from RYB 3 phases and a neutral. So from this one, so it will comes and stops at a ICTPN switch. If ICTPN switch is closed, then power will close. Will supply to the single phase preventer, and simple single phase preventer satisfies, then it is given to the starter. Starter satisfies, then will goes to the motor. The motor will work. This is the different stages. So motor can stop from starter, single phase preventer and ICTPN switch. So 3 stages we are going to control the motor. So you can see the operation, how it will work. You can see a small animation how the power is going step by step. Now here 3 indicating lamp RYB, 3 indicating lamps is the normal position. When supply is ICTPN closed, switch is closed, then it automatically glows. You can see here. Now the supply is coming here. So RYB input power supply. Then when ICT supply energy meter is ready, it will give the supply to the ICT directly triple pole switch, and it is ready to supply here. And once ICTPN switch is closed and the supply will goes to the another section, here it will goes to the single phase preventer. Then you can see the 3 lamps are glowing, R phase, Y phase, B phase. At the same time voltage and ammeter and voltmeter also indicates the what is the voltage, what is the current. So in this condition the ammeter indicates the 0 because motor is not switched on, and voltage will shows the line to line voltages. Now after 3 phases is available, 3 lamps is glowing, now 3 phases supply is coming, then single phase preventer satisfies, then it will automatically switch on the starter. Then so here you can see the from single phase preventer to it will supply is going to the starter, here star delta starter. From star delta starter to 6 wires, already we have studied this one. So 6 wires lines is connected to our motor. Now once again we have to start the button by pushing the green button and star delta starter. Then once star delta starter started, then it will give the supply to the motor. Once the motor is started, then automatically it works as to pump the water. This is a basic animation. You can observe how we are going to control our motors at different stages. Now, so this is one thing we are going to learn. Now let us do this is a wiring diagram, operation of the pump set, and how many stages we are going to control our motor. So if anything happen, we can stop at star delta starter, and we can stop at the ICTPN switch. If the problem occurred input itself, it automatically single phase preventer will take care of it. So these are the different stages the motor will run. Now let us see, we will take the one problem, same problem. So 5 kilowatts motor, how we are going to prepare the this schedule. Let us do quickly. Now so let us take one problem. Let us assume there is a 5 kilowatts 3 phase 400 volts squirrel cage induction motor as a power motor. Then now so here we are going to prepare the schedule, estimation and installation of schedule. So that purpose, so we know that steps similar to the previous case. What are the steps involved in the power loads? Now here first case, find the starting current of motor. First case. Next, how you are going to find the starting of the current? So by P is equal √3 VL IL cos phi, and we taken the power factor, we taken the efficiency. Based on this one, we are going to find the what is the full load current of the motor. Primary side, we convert the input current into 2 times we are going to starting current. That is the first thing. And second thing, choose the switch gear and protective devices based on given motor load current. after knowing the full load current into double times, 2 times, so we are going to get the some idea of the what is the starting current. Based on the starting current, we are going to choose the three phase voltages, at the same time current based on the this starting currents. After that, so find the metal conduit length from meter board to motor terminals up to, so this is the third length of the conduit. In previous case, in lighting circuit, we are going to number of horizontal runs, vertical up, vertical down, different loads. So from power loads only, so we are taking the vertical each power load as a separate the conduit, what is the, we can say the separate conduit arrangement from the source to load. Here we taken the only one single conduit, metal conduit we are using from source to motor. Now, so where we are going to take the, what is the horizontal length, what is the vertical up, what is the vertical down, where we are going to use the flexible conduit, we are going to measure by keeping our points of A, B, C, D. So length we are measuring the from A to B, B to C, C to D. So similar to previous cases, we are going to calculate the length of the conduit. That is the third point. Next point is the fourth point. Now find the length of the copper wire. After getting the length of the conduit into 3 times, we are going to get the length of the copper wire. Next, after that, we are going to calculate the calculation of labor cost. Then finally prepare the schedule. This is the same steps in estimation of costing of lighting load, estimation costing of the power loads in a small industry and workshop, a laboratory, a big industry. At the same time, same procedure we are going to apply here also, agriculture also. These 6 steps we are going to follow to know the what is the estimation costing of power loads. Now let us see one by one in quickly. So let us find the size of the wire cable. So here the size of the wire cable is equal, output power is equal √3 into VL into IL into power factor. So here efficiency is equal input by output, we already known. The percentage of efficiency is equal input by output into 100. Now the motor rating is given 5 kilowatts, that is assumed as a output power. Now the output power is converted into the input power by using this efficiency formula. Then what will happen? The input power is equal efficiency into output power. Then based on the input power, so we are going to find that, so load current, full load current. Now we are going to find the full load current. Full load current is equal total power by √3 VLI cos pi. This is we are given. So we require the current. So that is a full load current is equal to W into 1000 pi, that is the kilowatts, by √3 VL power factor into efficiency. By substituting these values from given value, we are going to find that, so 5 kilowatts into 5 kilowatts, 5 into 1000 by √3 into voltage, where line voltage is 400, sometimes we are going to 440, they are given the 400 we are assumed, into power factor we are assumed the 0.8 and efficiency we are assumed as the 0.85. So based on given values we are substituted here, we are going to get the 10.61 amperes as a full load current. Now based on the full load current, we are going to calculate the starting current. Starting current is the 2 times, we are going to the 21.22 amperes. So based on this current, so based on the available IE table, Indian Electricity Standard Table, we are going to choose the which type of the wire is suitable for this current rating. Now we based on this one, we are going to 3 square mm copper conductor is suitable for drawing this much of the current 21.22 amperes without heating anything. These are the cable we are find. Now so based on this one, we are going to 1 square mm copper cable is also suitable for, so taking the current to the pilot lamps connections and ammeters, voltmeter connection purpose. Now another is a size of conduit. The size of the conduit is equal 6 wires that runs from the star delta starter to motor. Here we are used the star delta starter. Star delta starter input is taking the 3 wires, but output will use the 6 wires from starter to motor. So that is the size of the conduit, so has to increases. Otherwise we can take the same common wire. So based on the, if it is easily to provide the 6 wires. Now so based on this one, here 25.4 mm heavy the metal conduit is used for this from starter to motor. Now So measurement of the conduit length. Now we are going to find, our aim is to find the metal conduit length. So length is previously similar to the previous cases. Length also can be calculated by using the horizontal length and vertical length, and vertical up, vertical down. So for this purpose we are going to place a number of points. So from point 1, point 2, point 3, point 4, point 5. So based on the points, so what is the distance between the point 1 to point 2? So different place 1. Now here you can see the point 1 is placed at the near energy meter, and point 2 is placed ICTPN switch. Here the distance is nearly 30 centimeters. Here instead of using the rigid conduit, I can use the flexible 25.4 mm, the flexible metal conduit. So the length, let us assume 30 centimeters, or we can say maximum of meters, that's 0.5 meters. Just let us assume it. Now, and third point is the third point. From third point to fourth point, this is from it is going to the third point to the horizontal run. From horizontal run to once again it is coming to the lower side, the single phase energy meter, this one. So here how much we are going to take? So here also length is very less. So then we can use the flexible metal conduit. Next 4.2. So fifth we are using to another. This is a 1 square mm the cables for this purpose. What is the purpose? Is pilot lamps and indicating lamps if it is required. Otherwise you can take the 5, from 5 to 6. What is the length? Here also we are using the flexible metal conduit. We can take the off meters, from off meters from 6 to, and here you can take the 6 to 7 is the amount. So how much length you have to take in here? So here the 6 wires has to draw the metal conduit. Now 6 to 8 is the another length. Here what will happen? From 6 to 7 it is coming to the nearby wall. At the same time 30 centimeters will enter into the depth of the ground, and we are using the underground. So it is avoid to any problem, and it is going to the depth, the 30 centimeters. It is running on the floor from that distance nearly it is 3 meters or 2 meters nearly, and from it is going to the 30 centimeters up, and from 30 centimeters to it is going to the plinth 30 centimeters. From that 30 centimeters we are going to give the terminal box. Here where is a problem, we can use the flexible rigid conduit or flexible metal conduit. Now you can see here. So here the length from, you find the length from this area. So this to this area, what is that we can assume is the L1, length of this one, and from pilot purpose we are using the length 2. You can observe the what is the length, you measure it, and length from this place to this place, what is the length? That is the L3. Thus from this to this place to this place, measure the length, total length. So L1 plus L2 plus L3 will give the total length of the conduit required for installation of motor. So this is the total length. For clarification, you can see here. For example, here is a one length. Once again, here you see a simple calculation. Here it assume this is a one room where, so given size is as per given dimension, where the 3.5 meters height, 4 meters is length, and 3 meters width as per our requirement. So we have to place our motor at this corner, 1 meter from this side, 1 meter from that side. That means from this side to, from left to extreme left to here. So we are going to only 4 meters, from that side to this side only 2 meters. 1 meter we are provided for the ventilation. Now so we are going to place here, this is one switchboard, here is our motor, and from switchboard to motor we are going to provide the conduit. So what are the, how we are going to conduit? Simply you draw the figure from this arrangement, that where we are going to energy meter, ICTPN, single phase preventer, and starter. From this one we taken the up to horizontal run. So because these all are provided from 1.5 meters from the floor, from 1.5 meters to 1.5 meters to reach the horizontal run. Next it is going to horizontal run. So up to nearby this motor. So this is a nearly 4 meters. So here what will it is going to the nearby motor on the wall. Next it has to come downward. So one is a from nearly this is a 3 meters. Now from this 3 meters to it has to go the on the floor inside 30 centimeters. It has to under floor it is going to the nearly 2 meters, and from this one it has to go this side and it is going to the cup side. That is the metal box, the terminal box. So this is the length we are going to count it. Now find the length. So from 1 to we are going to 2, and 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. This is the length we are going to find. Let us assume length in between this one. For example, 2 to 3 1.5 meters, and 3 to 4 3.5 meters based on the given dimension of the room, and 4 to 5 3.3 meters, and 5 to 6 2.3 meters, and 6 to 7 and 7 to 8 to terminal box we are going to 30 centimeters plus 30 centimeters plus 30 centimeters 90 meters. Now measure the total value, we will give the total length of the conduit. This is a simple thing. Already we have done this in lighting loads, we have done in power loads, and at the same time we are going to do the same procedure in agriculture also. I think you are very understand this very clearly. Now based on the sum of the total area, the 1.5 meters, 3.5 meters, 3.3 meters, 2.3 meters, and total 9 meters, that is total length of this one. At the same time from 2 to 1 we are used the 1.5 meters the flexible conduit to connect the energy meter to ICTPN to single phase preventer to the starter. We take in the other this one, and so we take in the another length also 1 square mm, that is other wire by using the pilot lamps and instruments, that is a different. This is the total length. Now total length of the conduit is required length from the 2 to 8 points. What is the distance between these two? That is from starter to motor. What is the length? We are going to provide it as per our diagram. We are going to calculate. Now let us see this one. Now based on this diagram we are going to calculate length of the conduit. So length of the conduit in the floor is nearly 2 meters. We take in the 2.3 meters nearly, so 30 centimeters extra, and length of the switchboard to motor base. So we take in the we added the total value 1.5 meters, 1.5 meters, 3.5 meters, 3 meters, 3.3 plus 0.9, so 10.7 meters. So based on this total length is equal that 2.3 plus this one we are going to get that. So nearly 13 meters, and 13 meters into 10% of the wastage we are going to get that. So 14.3 meters. We are assumed as a 14 meters length, total length of the 25.4 mm metal fixed conduit, rigid conduit is required. Next here from the energy meter to ICTPN switch, then ICTPN to single phase preventer to starter required the flexible metal conduit, that is a nearly 1.5 meters is a very required for the flexible conduit. So very less distance. This is already we have seen. Now so total length is 14 meters. So we know the total length of the conduit. Now based on the length of the conduit we are going to calculate the length of the copper wire, that is a conductor wire. Now length of the wire is equal length of the 3 square mm cable from ICTPN to starter. So 1.5 into 3 R phase, Y phase, B phase. So we are going to get the 4.5 meters. Now length of the starter to motor terminal 6 terminals. So we have taken the 1.5 meters plus 3.5 meters total length into 6 times. So we are going to get that. So 69 meters. Now what is the total length? Total length is equal 4.5 meters plus 69 meters is equal 73.5 meters. At the same time we taken as a 15% wastage at cutting at this corner. So we are going to get that. So nearly 85 meters length of the copper wire is required. 3 square mm copper PVC 85 meters required to connect from meter to motor connections. At the same time 1 square mm also is required. So here to connect the pilot lamps, that is maybe nearly 2 to 3 meters. Now length of the 1 square mm cable, that is the same cable used for the indicating lamps, 2 meters is enough. Now, length of the service wire. The service wire is required to connect the power nearby LT pole to our energy meter. So, 15 meters is the distance between the pole to our shed. Now, so 720, or we can say the 6 mm square. Generally 6 mm square aluminum copper cable, the weatherproof service wire, or we can say the length of the 720 LWG aluminum weatherproof twin core cable used for connecting LT pole to switchboard of pump shed is nearly 15 plus 2 meters, 1 meter here, 1 meter is extra. That is called 17 meters into 2 times because we require the 4 wires R, Y, B, N. Then we are going to the 34 meters plus or minus 15% wastage. So, we are going to avoid the sag. So, we are going to get that nearly 39 meters. So, we can take the 40 meters for this purpose. This is the length of the service wire. Now, the 8 SWG earth wire also is required. So, what is the required earth wire? Earth wire is required for at the same time earthing purpose as well as to keep the service wire in a straight position from LT pole to our shed. We are going to use this also. That is nearly 15 meters and 14 meters that is the GI wire for the earth purpose. Metal conduit should be earthed along this conduit. So, we are going to nearly 30 meters of the earth wire is required. These are the length. Now, after getting this one, so we are preparing the schedule. So, these are the main steps. So, 1, 2, 3, 4 steps. After that, getting the steps, we are going to conclude on a paper on the table. So, that is known as a table. Same 32 amperes, 50 500 volts ICTPN fused with the unit is 1 ampere is required, and star delta star is 1 ampere required, single phase preventer is 1 ampere required. Similarly, so what we have learned previously, same length we are going to calculate it here. These are the materials which required. So, dangerous plate, indicating lamps, cement and salt and coal for the earthing purpose, and service wire 39 meters, all what we have calculated we placed in a table. Now, finally, after preparation of the table, at the same time we are going to calculate the labor cost. Similarly, labor cost electrician charge plus 1 helper, total how much charge into number of days, we are going to get the sum of this one. These are the total calculation of estimation and installation of agriculture pump set for open well. This is a procedure. Now, modern pump sets you can see. So, how if we are estimated, installed in a perfect way, then motor will work perfectly without any problem. Then what is the application of this agriculture pump sets? You can see here. So, different, it can be used the agricultural industry purpose, the apartment purpose, different application purpose. The connection is our power connection is the similar way. So, the model agriculture pump sets. Now, nowadays we can observe the non-conventional energy source is the solar power also used to run our agriculture pump sets. So, that purpose how we are going to give? So, instead of giving the agriculture pump set here, the 3-phase, that is the DC panel, the PV, the photovoltaic panels is provided, and the top of the shed where it generates the DC supply, that is given to the inverter, where inverter it will take the DC, at the same the DC supply is given to the panel, DC supply is given to the inverter through battery, where it will charge the energy. At the same time, it will give the DC to AC conversion, and it will give to directly to our induction motors. But at the same time, so DC motors also used to run as a pump sets. So, single phase, that is a 1 HP DC motor I have seen on our polytechnic, where they have provided in Bellanpalli Polytechnic, where they are provided the nearly 1 kilowatt DC motor run by using the nearly 14 plates, each plate having the 150 watts plates provided and connected to the one, directly connected to the given to the motor set. So, nearly it will generate the 1 kilowatt. So, 1 HP is the 735 watts DC motor. So, completely run during daytime only. That means, so this by instead of taking the from Discom or Transco supply, so we can run the motor also by using the solar panel. So what to do here? So instead of taking the energy from the LT pole, we taking the DC supply from the overhead PV panels as a DC supply. So the DC supply is given to the, here is a what do you call, the hybrid inverter, where hybrid inverter will take the DC supply from the panel, and same is connected to the DC battery, where it is a battery storing the daytime solar energy stored, and then at the same time it will take the DC supply and convert into AC, whether it's a single phase or three phase, and it given to the our motor. Motor will run daytime continuously up to so sun is available. This is a connection, same process. Here there is no need of the single phase preventer. At the same time, we require the ICTPN switch is required, and starter is required, and connection is the same motor connections. But instead of using the three phase discom AC supply, you are using the panel DC supply stored in the DC battery. The battery DC supply is converted by using the inverter into three phase supply. That three phase supply is given to the ICTPN switch and starter and motor. This is the thing you have to remember. These are the things you should remember. Now, so what we have seen today, let us summarize. So type of wiring and service mains used for irrigation pump set. Next, various materials required for irrigation pump set installation purpose, and calculation of materials required and estimating their approximate cost. And lastly, we preparing the estimate for electrifying an irrigation pump set. So these are the things we have learned. I think you have any doubt, please clarify by seeing a reference books. Thank you very much for listening. Thank you.